Yes.
We're aware of an outage in your area and apologize for the inconvenience of the service interruption at street address 11701. This has affected your Xfinity services. Our technical team is working hard and expects service to be restored today by 7:44 p.m.
At the end of class.
Please note, an agent won't be able to help resolve the issue quicker.
All right. So, heard that, ladies and gentlemen? So you understand this is why I'm recording 4-1 for you. And so I am going to just record this session with you, or for you, I should say, so at least you have the notes. So section 4.1 has to do with historical numeration systems, and it's actually kind of a fun section. So I'm just writing down the name of what we're doing. And I purposely allowed that to play so you understand that today, on April 14th of the 21st, 2021, it is now 5:35. I've been attempting to log on, and I always say, show proof. So this particular section is dealing with Egyptian numerals. Oh my God. So Egyptian numerals. I can't talk and think here. Their numeral system is quite interesting. Just for the record, I also recorded lesson 8.6 ahead of this one as well, while I was waiting for the system to come back. This first example pretty much says write the number below in Hindu Arabic form. So in Hindu Arabic form, and so they begin by giving us Egyptian early symbols to note. So let me see if I could pull them up online. Oh, I can't go online. What's the reason I'm recording? Okay. Oh boy. This is a level of frustration that affects us because we know that we're tight on time. So here's what we do have. I'm gonna actually write out this particular number system. So they have the number, they have the symbol, and they have a description. So let's start with number 1. For number 1, the symbol is simply a scratch or a tally, and they refer to it as a stroke. Okay, the second number is a value of 10. They refer to it as a heel bone. The third value they give you is the 100. They refer to this symbol as a scroll, and that's literally the design they're looking at. This is a very unique math section, so just bear with. The 1,000 is what we refer to as a lotus flower. The best thing I can do to draw this is think of it as like a little triangle at the bottom with a little set of whiskers, and then over here there's some sort of little flower. That's called the lotus flower. Now the 10,000 is funny looking. We refer to it as a pointing finger. Literally looks like a finger. So pointing finger. And this is good to know, especially if you ever become a teacher or you're thinking of maybe becoming a teacher, because we do discuss these things historically. And the 100,000 is what we call the burbot fish, and it looks like a little blob with a smiley face. This is called the burbot fish. And lastly, the 1 million mark is referred to as the astonished person. And they've updated these books because it used to be called the astonished man, but now they're like, no, the astonished person. The way I always think of this one is it's supposedly a person, but it looks like a bowling pin with two little arms sticking out of it. And it looks like it has feet. Sort of like that. So they call it the astonished person. Now, in this example, I'm going to go over the 4 examples that are in this particular chapter, which are, actually there's 6. They go into Chinese numeration, 7, 8 examples. So there are 8 examples. All right, so very patiently here, using the symbol, we're going to actually discuss this. So in example 1, I'm almost better doing this instead, so if you bear with me, am I going to be able to do that? I'm not, because I can't. Okay, so here's what we have. We have 2 of the burbot fish. I'll do it this way instead. We have 3 of the lotus flower. We have 5 of the scroll. We have 9 of the heel bones. And we have 7 of the strokes. And so numerically speaking, I've given you the value of the burbot fish. So here we really have 200,000, right? Because 2 times 100,000 is 200,000. We have 3 times the lotus flower, which is 3 times 1,000, so we really have 3,000. We have 5 of the scrolls. The scrolls are 100 each, so that we really have 500. We have 9 of the heel bones. The heel bones are 10 a piece, so 9 times 10, 90. And 7 of the strokes, which is a value of 7 times 1, so 7. And now we add that up, and you should have a total of 203,597. Okay, so that's the essence of this question, and they're going to give it to you in symbol form. I didn't. I gave it to you in description form, but I gave you both, so you have both. All right, so that's that example. Then they ask you in the next question how to take a number and replicate it using this information. So if I were to take this and I were to draw it out or write it out in Egyptian form, I would go backwards. So let me go ahead, because I want to be able to see all of this information. And so I'm going to just erase what I just wrote. And this is example 2 that I'm going to do here on the side, just like right next to this. So in example 2, we have creating an Egyptian numeral. So we are creating an Egyptian numeral. And so what they're going to ask us to do in this question, in this example, is to write. Notice they're giving us the value 376,248. So we begin by the fact that we have 3 burbot fish. So 3 times the burbot fish. So you would draw 3 burbot fish to answer this question. We have 7 pointed fingers. And again, I'm not drawing them, but you can associate the drawing with the word that I'm giving you. So you would be drawing 7 of these things here. I'm not going to bother with that. 6 lotus flowers. We would have 2 scrolls. We would have 4 heel bones. And lastly, we would have 8 of the strokes. So your answer for this question would actually look more of a drawing. So you would have the little squiggly fish. You had 3 of those guys. Sorry, my drawings are not. That's why I was like, you know what? I'll just write it out. So you got 3 of those, and then you've got 1, 2, 3, 4, 5, 6, and 7 of the pointy fingers. The lotus flowers, we would have 6 of those, so it's kind of a lotus, right? So it's the best I could do for now. So we would have 6 of these. Okay. Okay, sorry, I'm trying to do the best I can to... All right, so 6 lotus flowers. We would have 2 scrolls. So 1, 2 of those scrolls. And then we would have 4 heel bones. So 1, 2, 3, 4 heel bones. And 8 of the strokes. So 1, 2, 3, 4, 5, 6, 7, 8. This is actually what they want you to answer. I promise you that on the homework, the way that Pearson has done it, you all simply need to select the value and you're good. So this is examples 1 and 2. Example 3 is really no different. We still are using these values. So in example 3, we're actually subtracting. We're subtracting Egyptian numerals. All right. And so if we begin with part A, in part A they're giving us the following question. We've got, it looks like 1, 2, 3, 4, and 5 of the scrolls. You have 1, 2, 3, 4 of the heel bones. And it looks like you have 7 of these strokes. So 1, 2, 3, 4, 5, 6, 7. I'm just replicating what they're giving us. We're taking away from this 1, 2, 3 scrolls, a heel bone, and 1, 2, 3, 4 strokes. All right, and so when we subtract these, if you notice, I mean, common sense, if I'm subtracting 3, I'm left with 1, 2 of the scrolls. I'm left with, if I subtract these, I'm left with 3 heel bones. And if I take away 4 and 4, I'm left with 3 of the strokes. Okay, and if you regroup that, you'll still have the same or similar value. Okay. I'm going to show you part B. in part B, I have scroll, scroll, heel bone, heel bone, heel bone, stroke, stroke. I'm missing a heel bone. All right. We are going to take away from this one scroll, 2 heel bones, and here I have 1, 2, 3, 4 of the strokes. So what I want you to notice in this case is I have to regroup. So the heel bone, if you recall, is equal to, heel bone is equal to 10. So I'll have to borrow from this place or from this heel bone. So if I borrow a heel bone, this is now 12 because this now has, I've taken this away, and now this has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So basically 10, 11, 12. So now I'm going to subtract from that 4. And 12 minus 4, well, that's going to leave me with 8, right? Because this is 4, so that's 1, 2, 1, 2, 1, 2, leaving me 1, 2, 3, 4, 5, 6, 7, 8 heel bones. I borrowed 1, so 3 minus 2, well, that's just 1 heel bone left. And 2 scroll minus 1 scroll is just 1 scroll. All right, and so in that one, you actually had to borrow. All right. Let's look at example 4. In example 4, we have to use the Egyptian multiplication algorithm. So we'll use the Egyptian multiplication algorithm. All right, and so in doing this, it says a rectangular room in an archaeological excavation measures 19 cubits by 70 cubits. A cubit is based on the length of the forearm from the elbow to the tip of the middle finger, and 1 cubit is estimated to be equivalent to 18 inches long. Okay. Find the area of the room. And so we begin with, in this case, if we do the multiplication and we do basically 19 or 70 times 19, let's see, let's do simple math here. All right, so multiplying in this case, so 19 times 70, well, that gives us 1,330, which is the area of the room in cubics. This would be in square cubits. Now don't mistake that with cubic. So the way they do this is basically, we know that we have 170, 1 times 70, 70. We know that 2 times 70 is 140. We also know, if we continue the math, we know 3 times 70, 210. We know 4 times 70 is 280. And we continue this. If I do 8 times 70, I get 560. And if I go as far as 16 times 70, I get 1120. And so I know that in this case that 70 and 140 and 1120, that should equal 1330. So we are going to each column in this case. So if I'm building the columns like I was starting to, where I have 1 and 70 as my start, each column is built downward by doubling the number above. Okay, so if I'm doubling, that's why this 310 doesn't even fit here. It's not a multiple. So if I double this, that's where the 140 comes from. If I double this, that's where the 280 comes from. If I double this, that's where the 560 comes from. And if I double 560, I end up with 1120. And so the first column, in this case, we have 1, 2, 4, 8, and obviously 16. And so if we add 16, 2, and 1, the total is 19. And that is the qubits. Ironically enough, if we add 70, 140, and 120, we end up with the same square qubits. So that's the idea of this question here. All right. Now, example 5. In example 5, we're subtracting Roman numerals. Okay, so let's review them for a minute. Now, the beauty of subtracting the Roman numerals and knowing them is you need to remember that there are some conditions. They're listed on page 147 in your book. So, one of the addition features is that we have 1, 10, 100, and 1000. We also have symbols that denote 5, 50, and 500. Okay, we also have the subtractive features where the I value can precede. So it could either be preceded by V, so you could have like V like this, or you can have an X with the I value preceded. So like this would be 6, this would be 11. Subtractive, if it's on this side, then now you have 4. So it's 5 minus 4 is, 5 minus 1 is 4. If you have this, okay, actually that only works with the 5s. Let's see here. So the other one to consider is the X, or the 10 symbol, which is preceded only by L or C. So remember, that's basically like if you have 49, the number 49 in Roman numeral would have to be X with the L with the X in front of it, and the 9 would be denoted by I with the X following it. So hence 40 and the 9 part, and so added together 49. All right. We do have a multiplicative feature, which is basically putting a bar over the value. So as I do the questions, I'll discuss this with you as well. So in this case, it says you have 26 guests that were invited to a banquet, so 26. And it says if only 14 of the invitees decided to attend, then how many guests are at the banquet? So that means that if we take away 14, how many guests are at the banquet. So if we regroup this and you consider this as basically 20, and then you have 1, 2, 3, 4, 5, 6. So we're regrouping that number. And here I am regrouping the original 14. So this would be x, which is 10, and 1, 2, 3, 4. And now I can subtract easily. So in essence, I'm just going to, we're just going to take away 4 of the ones. So that's here. And that's going to leave me with 12, basically. I'm sorry. Yeah, 12. Yeah. Because the x's will cancel, leaving you 1 x and 2 of the i's. Okay. They do talk about the Chinese symbols. It's very similar to the Egyptian symbols. So in example 7, they get into that. They start talking about interpreting Chinese numerals. So you have to look on page 149 for the chart, and that's in Pearson as well. And so they give you some numbers. We're going to go 1 through 10. Starting with 1, so this is the number for number 1. And then the symbol for number 1 is actually like a dash. For the number 2, it's actually 2 little dashes going this way. For the number 3, it's 3 little dashes with the smaller one on the inside. Number 4, it almost looks like a set of goggles. It's weird, the symbol. It's like this. For number 5, it looks like one of those bike machines, elliptical. Number 6 kind of looks like a person. You kind of have, that's a little extreme on the top. That's kind of what it looks like. Number 7 looks like a T chilling out in the air. Number 8 looks like lambda. Number 9, it looks like an N. I don't know the names of these symbols because I have never actually studied Chinese as a language. I'm sure you guys will look into it. So for 100, it looks like a really, like a bell. Kind of like that. For 1000, it looks like a cross, again, with a little hat on top. And 0. Now 0 is intense. And everything means something, so you have to kind of like, for 0, it's like, looks like the hands are of a person. And if there's a body here, and it's like 4 lines going this way. So it's kind of intense. You can look at it in the book. I'm sure it'll make a little bit more sense to you. There are also some features of the Chinese system that we need to remember. So a single symbol rather than a pair denotes the number of ones. It says the multipliers of 1 through 9 is written, but the power of the base 10 to the 0 is omitted. In the tens pair, if the multiplier is 1, it is omitted. Missing powers of the base, the following rules are used. When a particular power of the base is missing completely, the omission is denoted with the 0 symbol. If more than 2 powers of consecutive powers are missing, just 1 0 symbol denotes the total omission. Why don't we look at a question and let's make sense of this? Because every time I teach this, I refresh my memory, to be frank with you. So this one, example 7, says interpret each Chinese numeral. Okay. And they begin with A. And in part A, here's what they give you. They give you the 3. They give you that was the value of 1,000. Then they give you the flat. This one was 1. Then they give you this 100 symbol with the bell. I call it the bell. This one here, where it looks like it's a person running, I look at it as these are legs and it's like a head. And then you have what looks like a T, and then what I call the goggles. Okay, and again, not appropriate because that's not really what it says, but so when I look at this as 3,000. So this is 3 times 1,000, and that equals 300. All right, so that's those two together. When I look at this times this is 1 times 100. When I look at this times this, I look at this as 6 times 10, which is 60. And this is going to be 4. And this will be times 1. So this will basically be 4. Right? And so this is how we would represent 3,164. So just remember, it's kind of like number, see how they match? And then this is by itself, so this is the single. That's why it just simply was the number 4. So it's like your ones. All right, let's do another one just in case. Let's look at this example. What if in this one you have the T that lays, and then what looks like a bell, right? And then you have what looks like that 0, right? Because remember, the 0 has those 4 lines on top of it. It almost looks like a person. And I do apologize if I'm offensive here. I'm just trying to do my best to replicate this. This is what we have in this example in part B. If you remember the symbol for this resting T, it's 7. That's this guy here. So this is basically 7 times 100. So that's those two together. The 7 is denoted by this, and the 100 is denoted by the bell. You can see that right here. Here's your 100. Here's your 7. All right, and then we continue forward. Remember, this is a placeholder. So this is 0. And then this is a single 3. So this is really representing 703. That being the placeholder. Okay, and that 0 being this crazy looking thing I drew here. All right. You can also go backwards. In example 8, they actually have you create the number. So they want you to write 814 in Chinese using the Chinese number system. You know, again, you're going to have this already written for you or drawn for you. You just have to select the correct symbols. So if I look at the 100, the 814, this is 8 times 100. This is 1 times 10. And basically this is 4 times 1. So the 4, if you remember, those are the goggles. That's a single. The 1 times 10 is simply going to be the little crisscross T that I originally drew. And the 8 is going to be the backwards lambda and the bell. The bell looks kind of like this. And so those are your values. Because there's only one of these, that's why it's standalone for this one also. Now, if you want to do one such as, we're going to write $5,090, then in this case, remember this is 5 times 1,000. We have 0 in the hundreds place, so that's 0 times 100. So that's going to be that crazy looking, looks like a person basically. That's a 0 mark. And then, so you do have a placeholder. This is the one that I say looks like an elliptical. So that's this one. And the preceding should be the T with the hat on. Where this is a little longer, this is a little shorter. And then lastly, 9 times 10 for the 90. So in this case, you would do the N. Remember I said it looked like an N. And then the T, relaxed T. Okay? So that's the recording for 4.1. It's kind of a strange chapter. Just take it in. Information, little by little.